this is a brief introduction to what the technology is, what it can afford us. Maybe I'll introduce some concepts that we will be using throughout the workshop. And if this is all familiar, then I'm very happy. That then means we are all on the same page and very, very well aware. But I hope I will bring something new and interesting as well for you. So virtual reality is a technology that works on the principle of replacing the real world with a virtual, or that means with a digital or synthetic. And the objective of any virtual reality technology is to actually create an illusion for the user that the real world around the user doesn't exist anymore, and there is another one which is digital. That is where the users are, and then this is where they act, and then this is what they experience. So virtual reality relies on replacing the sensory input. So we, as humans, we perceive the world around us through our vision, our hearing, and touching things, and also having some sense of balance. And with virtual reality, we try to replace that with something digital. Mostly people think about the visual experience. So you put on glasses and then you see something else, but there is much more to that. So creating the illusion that you are in a completely different place, or maybe you are in a very similar place, but not in this physical reality. So there are two effects that the technology tries to achieve, is to first block you from the real reality, and then also generate for you something very believable that is digital and synthetic. And maybe you also are familiar with the reality-virtuality continuum, where virtual reality is something on the right-hand side of the schedule of this scale, and the real is on the left. And as you go from the real environment, you can design experience that is partially replacing the real world with something digital, and approaching the right-hand side, you will be blocking more and more the physical environment and replacing that with digital. And of course, you can't, with the current technology, you can't achieve a total block of the physical world. You still, as a human, you feel your sense of gravity and balance it, and it still comes from the real world. And also with some technology, you could potentially hear something, and you could touch, and you can hit the walls sometimes if you are in a smaller room when you play VR. So you can't really fully block it, but at least you try to achieve that. And that contributes, and it's not only something that this technology does so that it exists, it contributes to the experience of the users. It works in a way better if the users actually experience technology and they experience the digital world instead of physical. And that contributes to the goal of the application. If the goal of the application is to play a game and entertain, you will be entertaining better if the user is fully in the game and forgets about the physical world around. And if you're doing an educational application, the users will be learning better if they are fully in there and they are not in the physical world anymore. So there is a concept that needs to be introduced. It's called immersion. And immersion is not something new, but this is something that has been really improving and realizing with the help of the virtual reality, the modern virtual reality technology. But there has been many different tricks and attempts to actually create this sense of immersion with something else, with good storytelling, with some theater tricks, with the circus, with the other older devices and technologies. And in a sense, creating immersion is basically creating the feeling in the human that they are somewhere else, immersed into something else. And that's also exactly what the modern VR technologically tries to achieve. And yeah, we just have a different device, and we have a better simulation, but it's still a search for immersion with the new and modern technology. All right, I can also introduce a little bit of the other concepts, how virtual reality works, and I want to introduce the concept of tracking. I have an illustration here which is a little bit outdated, but it still helps to understand what tracking is. And in order for virtual reality to work, you don't just show the image on the VR glasses, but you also need to respond to how the user or the human behaves. So if I look to the left with my hand, and when my glasses are on, I need to also turn to the left in virtual reality, in the digital world. That means the whole world needs to turn basically exactly the same angle, exactly the same moment in time in the opposite direction. So I perceive that I actually look at something else in my digital environment that is to the left from me. In order to enable that, so there needs to be a tracking. So some technology needs to understand where my glasses turn that I wear. So this can be done either with external sensors or with internal sensors. So you can place the sensors in your physical environment, the sensors that will be looking inside the room and try to position where the device is, or vice versa. They can be actually built in the glasses and look outside into the physical sort of shape of the room and measure constantly the distance to all the walls and the floor and the maybe other objects, and then position themselves relative to the physical environment. And that needs also to happen very quickly. So there is a well-known challenge of cyber sickness, and even with the modern devices, sometimes after people use VR for some time, they become a little bit seasick. And with the older technology, that was even older. I mean, 5-10 years ago was even a bigger challenge. So a lot of this cyber sickness and seasick effect comes from the delay between, or the mismatch between how my body physically perceives what I do in the physical world and what my digital world gives me input as a visual or audio input. So if I turn my head in my physical world and then the VR reacts half a second later, then this will make me very sick. So it needs to be not half a second, but much, much, much faster. Then this delay will be almost unnoticeable or unnoticeable, and then it will reduce or significantly reduce the seasickness effect. So this is about tracking. So something is constantly tracking how I move my head, but also lots of VR has controllers, and they are also tracked in exactly the same way. So that actually helps quite a lot for me. If the tracking of hands and controllers is done well, this helps people to actually feel stable and feel that virtual reality environment is real in a way, is a real illusion, and they can basically do something with their hands, and that helps basically to feel that everything is right and I'm not getting seasick. And it's also possible to place additional sensors. There are other devices, there are other applications that allow people to place sensors on legs and other parts of the body to create a more realistic body movement that is usually for in the collaborative session for others to observe our own avatars. Tracking and immersion together is just a very short old video that shows that the same thing that I was talking about. So a user is moving his head here, his hands, and sees that the environment basically reacts to the movement. So tracking contributes to immersion. So there are virtual reality systems that don't really require a lot of tracking. So they're a bit static, and very, very often you can see them, and they're quite popular. They are based on static environments like 360-degree or spherical photos or videos, where the tracking is only basically 3 degrees of freedom. You can look left and right, but you cannot really walk and step left and right. And you don't really need also tracking of your hands in this kind of VR environment. But yeah, better tracking contributes usually to better immersion. I can also introduce the concept of interaction. In the physical environment, we don't think that we are interacting with something. If I'm picking up an object from a table, I'm not thinking I don't need to do any complex calculations. How do I do it? It's very natural. It's very easy. And in a virtual environment, in a digital environment, this is very different. So think about interacting with your mobile phone or laptop. How we use keyboards and touch screens and mouse and also voice commands and so on. And in VR, it's also slightly different, right? So you can interact with something like a flat window that is hanging in the air in front of you, and then it's different in VR because you can actually walk closer or further away from an object. So if I have a menu in VR and it's a bit small, I can just make a couple of steps forward. So this couple of steps is also a part of my interaction. Or if this window is too big, I can take a step back and look at it. And also, if I'm interacting with something that is not a flat menu, but it's a three-dimensional object, if I want to study animals, say I can bring a 3D model of an elephant in the middle of my room, and I can basically walk around it. And that walk around is also an interaction with the environment. Lots of VR devices provide controllers, so it's very easy to track where they are in space, and also they provide you with the options to click different buttons, and in the application you can program what every button can do. But also more and more there is hand tracking and hand interaction, so that you just don't need any controller and you can just use your fingers and use gestures like tapping on something or like zooming in. And basically this makes the interaction a bit more natural. So I can pick up an object with the same gesture I would pick up the object in the physical world. I can click on some virtual buttons in the same way I click on a physical button with just tapping my finger on it. So that is also a big step forward in VR. This comes also from other similar technologies, is gesture recognition. And basically this works in a way that modern VR glasses have sensors and cameras that look down at the hands of the user. And yeah, so you see the left hand here is tracked on this little video. And then you can also program standard gestures. The same way you program standard gestures like swipe left and swipe right and long tap and a regular tap on a mobile phone, you can program this tap gesture or this zoom gesture or something similar on in a VR system. I can also say a little bit about navigation. I think you're all familiar with navigation in virtual reality, that you usually in many apps at least you can teleport from place to place. So that's teleportation mechanic is common. However, there are different ways of doing it. So there are ways of making locomotion work, meaning that you can actually smoothly move in virtual reality and not only jump from position to position. However, it's a little bit challenging, and many people get seasick, and that's mostly because in physical world you stand on your 2 feet, and then if you start moving in the virtual reality environment, that makes you a little bit uncomfortable. However, there are some tricks on how to make this work. For example, like making you move slowly or making you feel that you are in a vehicle, like in a car, and then you tolerate this a little bit better. Or another option is also to dim the screen a little bit, dim the peripheral vision, and only leave a smaller field of view that is sharp, and then also that prevents some of the cyber sickness. The other option is actually to create the VR environment where you don't really need to go very far. And then you can then use your physical movement. And if you have, I don't know, 2 by 2 meters space in your living room where you can play in a VR application, and then you can think of the virtual reality design that you can design a space in VR where you also don't need to move very far. So you can have a workstation and simulate the work of someone who's the conveyor belt, and you don't really need to go very far. It's enough to make a step left and step right, and then it's really, really natural. You don't need to think of moving somewhere or jumping somewhere. You can just move in the same ways in the physical world. Okay, so that's a few words about navigation. Yeah, and the teleportation mechanic, I will not stop on that. It's apparent from the video how that works, and that's a good backup solution for any situation. I can say a couple of words about embodiment. So in a virtual environment, we can have a visual representation, we as users or humans. And yeah, in many VR environments, you can also customize how you yourself look. Can be human, can be even something else. Like in many computer games, the biggest value of that is also in the collaborative mode in virtual reality, when there are other people in the same environment that they can observe you. And yeah, from the visual appearance, the avatar that you can create for yourself, you can make it look like you, or you can make it look like somebody else. And if you want to stay anonymous, you can create an avatar that it looks very neutral. You can create an avatar that looks not even as a human, or you can vice versa, create an avatar that looks very formal, or maybe it looks exactly like yourself. There is a big body of research and also design on what to do and how to work with avatars. There is also a possibility to create additional characters that are not represented by humans, but by AI, would have some role in the virtual environment, like they would be playing the role of humans. And that also gives quite a bit of value to the environment. And of course, you can create sort of characters, not only how they look, but also what they say and what they do for different roles. And with the AI and the modern generative AI, you can do quite a lot with the characters. So we are familiar with the regular chatbots, and in virtual reality, basically this chatbot that you text on the web page becomes then a human that you look at, and then instead of texting, you can actually say things, and instead of reading the text, you can actually hear the reply. So that's the advantage and the difference. And the characters in VR can also communicate not only through what they say, but also how they look and where they are and how they gesticulate, and they could also point at different things and yeah, make you aware of something or give you instructions about something. So they really create an additional value to the text-based chatbots. For example, in one of our applications, the AI character points you to different pieces of equipment while giving instructions what you need to do in that workplace. And that I think helps a little more than if the same instructions were in a document, for example. But yeah, I can also mention it's not really fully explored with what you can do in virtual reality with generative AI. In one of the sessions later today, we will look at this a bit more. I can give you a few more use cases of virtual reality in education. It's not a comprehensive overview, but some of the use cases that I think are most prominent or valuable. So VR allows creating authentic learning environments. In this case, There is an example of a language learning scenario where you learn about directions and orientation in a new city, and you can create a few blocks of a city and learn the directions really by looking around and asking, okay, how can I go? How can I get to the pharmacy? And then you just look around, where is the pharmacy? And then giving directions or receiving directions that you need to walk one block forward and then turn left. They sort of are more realistic and potentially more learning rich and easy to remember. Or another example here with a 360-degree photo plus actors playing and explaining about some hard-to-reach environments like the Arctics or Greenland in this case. You basically teleport to a place that is you would probably never go without the VR, and also hear some researchers who work there telling you about it. There is another example here of our job interview simulation application. It's not only to simulate a different place, but also simulate a situation like a job interview where you as a learner would actually feel that you are there, and you would feel that you need to reply to questions and feel a little bit of pressure and a little bit of stress, and learn how to cope with that and how to deal with that. So we used, in this case, spherical videos and some scripted logic that the different video clips are selected based on how you reply to the questions. Another scenario is collaboration. You can use multiple things in collaboration. So you can have a meeting instead of in a laptop and a screen. If you would like to have additional visual cues, if you would like to have something in this space, not only speak on the phone, and especially if you have multiple people there, that would have a benefit. Another one that also would allow you the same collaborative scenario, also build a custom environment around you, use some normal classroom tools like flip chart or whiteboards, bring some objects, write some text. And of course, you can do also standard presentation plus slides. And especially during the pandemic, these environments became quite popular because people were just very tired of looking at the flat screen all the time and the black squares with the names of those people you were talking to. You could do quite some with artificial intelligence even before the recent spike of popularity with generative AI. And AI can do other things than generating replies from a large language model, such as speech recognition, for example, or a speech generation. So with the even scripted dialogues, it looks or it feels quite realistic, like in this example of Mondly. You can train on language and this example in realistic situations. But of course, with the same technology of speech recognition or speech to text conversion and then text to speech, if you put the large language model in between, this may become very, very realistic and very powerful. And maybe with the more visual technology, we can reach something that was, 5-7 years ago, very futuristic and becoming very, very real already today.